Hello, myself Varun Kumar, and in this video, I'm just gonna tell you how I understood the code for hack CPU. This is the given diagram for the architecture of the CPU. CPU works with a teamwork of several logic gates such as ALU, A register, D register, PC, and the multiplexer MUX. So to design the code, we need to derive the API of the CPU. API consists of chip names, input and output, and the function of CPU. Now after the abstraction, here are the inputs and output pins of the CPU. It consists of three inputs, namely instruction, enum, and reset. Instruction comes from the instruction memory that shows the value of selected instruction memory. The instruction can be either A instruction or C instruction. CPU takes in the instruction from the instruction memory, that is ROM 32K. Reset is the value to tell whether to bring CPU to initial state or to start the CPU's operation all over again. The outputs of the CPU are connected to the instruction memory and data memory as well, namely output names that are write_m, out_m, address_m, and PC. PC is program counter. This is the provided code for the CPU and resources of task 9.3D. I will explain this code in subparts line by line. Firstly, we have the header section for the code, which consists of chip name and names of input and output pins. The name for the chip is CPU as we are implementing it for CPU. Input pins consist of 16-bit enum, 16-bit instruction, and a reset, whereas the output pins consist of out 16-bit out_m, write_m, 15-bit address_m, and 15-bit PC. This is the first part of the part section of the code, which consists of a NOT gate, AND gate, and a MUX16 gate, which allows the CPU to perform specific operations. There are two types of instruction that comes into CPU, namely A instruction and C instruction. The NOT gate tells the whether the instruction coming into CPU from instruction memory is a instruction. The CPU decodes the 16-bit instruction to an opcode and the 15-bit value. If the opcode is 0, the instruction is an A instruction, and if the opcode is 1, the instruction is C instruction. If we have A instruction, the CPU stores the 15-bit value into A register. From the diagram, the A register can be fed up by either instruction input or the ALU output. If it is a C instruction, then the computation occurs in the ALU and the ALU output is stored in A register. We use AND gates to determine that the instruction is a C instruction. 16-bit mux is used to select whether the instruction or the ALU output is to be stored in register A. Now next part, we have a OR gate. The load bit in the A register will be 1 if either the instruction A or the ALU output is stored in A register. On the other hand, the A register is used to store the value that is fed into the A register. It takes the output A register in from the mux and the output load A from the OR gate as its inputs, and the output A out generates the value that is currently stored inside the register. Then we have another mux16 which takes the output of A register and the value that is currently selected in the data memory register in M. This mux will select which one to output, A or M. Depending on the 12th bit instruction value, the either value will be fed to the ALU. The AND gate is used to determine whether the ALU output is loaded to D register. The D register is further implemented to load and store the value of D register from the ALU. Next is the ALU gate, which computes a function on two inputs, which is the value stored in the D register and value of either A or M register. ALU consists of control bits that are Zn, ZX, NX, ZY, NY, F, and NO, which indicates which function is computed on two inputs. Function is computed on two inputs to produce output, whereas the output control bits that are ZR and NG determines the property of the result. The two ORs and sets the ALU value to write on the data memory. First OR determines the address of the write operation while the other one determines the content data memory, and the AND gates output a value that allows CPU to write the content to the data. Lastly is the program counter. Program counter is also known as a register which contains the address of instruction to be fetched next. In this part of the CPU HDL code, the load bit of the PC is determined by the jump bits and the ALU outputs. In this part, it determines the jump conditions and checks the ALU output to see if the conditions are met. If the instruction is C instruction and the conditions are met, the PC is loaded with a value that will tell the CPU to jump to the specified value. If the PC is not loaded, then the PC is in if this PC is not loaded, then PC is incremented and moves to the next instruction. So this is how I was able to understand the HDL code for hack CPU. Thank you.